Hello everyone, welcome to the machine learning course. Please get ready. We are about to officially start our class, and I hope you all can gain something. Welcome back to our machine learning class. In this class, we introduce you the decision tree algorithm. Let's take a look at the fundamentals of the information theory, which is the base knowledge of decision tree algorithm. First, let's look at the self-information. The concept of self-information is the logarithm of the reciprocal of the probability of random event. The unit of self-information depends on the base of the logarithm used. When the instant occurs, it indicates the uncertainties of the event and also indicates the amount of information provided by the event. Let's look at an example. Here, there are two kinds of news in the weather forecast, sunny and rainy day, and the probabilities of the occurrence is below. We can find that based on the information model presented in the graph, we can calculate that the self-information of A1
is 2 and the self-information of the 2 is 0.415.
This demonstrates that messages with smaller probabilities have larger self-information values. By using the relevant code, we can calculate the self-information values for the occurrences of letters E, C, and O. The average uncertainty of all possible messages emitted by an information source is called entropy. The calculation formula is as follows. Now let's consider the case based on the weather forecasts provided for two locations, A and B, about a future day. Let's calculate the entropys of the weather forecasts for these two locations. According to the formula for entropy, after calculations, we determine that
the entropy for location x1 and x2 are 0.809 and 1,
respectively. Another concept we should know is conditional entropy. Conditional entropy refers to the uncertainties that remains in the destinations y while receiving information emitted by the source x. Here the practice exercise to enhance your understanding and calculation of traditional entropy. And let's determine what the corresponding entropies is for this probability distribution. Let's move on to the concept of information gains. The information gains refers to the reductions in uncertainties of information source after receiving additional information. Information gain is calculated by subtracting the conditional entropies from the unconditional entropy. The larger the information gains, the more favorable the feature attribute is for determining class values. Now, let's move on to know how to build up a decision tree. A decision tree is a trace structure where the attributes of samples are used as nodes, and the values of attributes used as branches, and the leaf nodes are represented as category values. The decision tree algorithm can be categorized into three types: the ID3 algorithm based on information gain, the C4.5 algorithm based on information gain ratio, and the HART algorithms based on the Gini index. Now let's first take a look at the ID3 criteria. The ID3 was calculated by the means of information gains. The biggest attribute is the classification features based on the greedy strategies. The decision tree space is searched from top to bottom, and the decision tree is built through recursive
mode.
Here, let's consider a case where we want to use decision tree classification algorithms to automatically assess whether it's suitable for playing baseball based on the weather conditions. The graph represents the collected training data, where weather up to wind speed represents the feature attributes, and the ActiveChoose represents the class attribute. Watch this graph and think in your mind how to calculate the value of each activity based on calculating the uncertainties of category activities. Upon observation, plays appears 9 times and don't play appears 5 times. From this information, we can utilize the entropy's calculation formula to determine the value of H. Let's continue to calculate the conditional entropy. First, we'll start by examining the conditional entropy between the variable workout and the variable weather. We'll begin by separately listing the probabilities of workout in the data and listing the probabilities of different weather conditions in the data. And next, we will calculate the probabilities in the cross-table 2 features, weather and workout. Using the formulas for cross-entropy, we will calculate the entropies of workout for each weather condition, and finally we obtain the conditional attributes of the workout labels attribute with the respect to the weather featured attribute.
According to the conditional entropy formula,
we can calculate the entropies of the feature workout with respect to the feature's weather. Make it clear how conditional entropy is calculated. Let's go through the process of
calculating the conditional entropy
of the workout variable with respect to the weather variable once again. In summary, the calculation method for conditional entropies involves summing the products of the probabilities of xi under different conditions x and the entropies of y with respect to the xi. Once we have the probability distributions table of y with respect to x, it becomes straightforward to substitute
these values and calculate the conditional entropy.
After calculating the traditional entropies of each weather conditions, we sum up these values to obtain the traditional entropies of the workout variable with respect to the weather variable. And here we use the formula we can get the value the entropies of workout variable with respect to the weather. Similarly, we use the same way we can get the other entropies values of workout with respect to the other attributes such as temperature, which is calculated as 0.911. And here is the workout traditional entropy when the moisture is known. And you can post here and calculate by your own to check if the value is 0.789. And here, I will give you a few minutes
to calculate the conditional entropy when
the wind speed is known. And you can post a value here and check whether the value is right. Finally, we can get the information gains for each characteristic attribute, and we can find the attribute with the highest information gains is the workout attribute with respect to the weather. And then, based on weather attribute, we divide the data into 3 sections according to the levels of the attribute, which are clear, cloudy, and rainy. We can represent these differences using a tree-like branching visualization, which is what our decision tree looks like. And in this diagram, each branch represents the various levels of the attribute, while the circular node represents specific attributes. So, this concludes today's course. We introduced you the fundamentals of information theory and decision tree algorithms. And we also introduced a crucial concept, which is the entropy and traditional entropy. And for an example, we introduced you the ID3 decision tree algorithms and show you how to calculate ID3 decision tree. So this is today's course, and we will see you again in the next lesson.